Welcome to class. We are still in the business of discussing electrolysis. Electrolysis. We've explained the electrolytes, what they are. We have explained electrodes, the conducting wire or rod through which current or electron move inside the electrolytic cell and leave the electrolytic cell. We have also explained in summary what an electrolytic cell is, which is a cell that converts electrical energy to chemical energy. Because after the process, a chemical is produced. A chemical in the form of compound or in the form of what? Elements. In the form of elements, they are finally deposited at the anode or at the what? Cathode, where they are being collected. Okay. How does it work? In our last class, we were able to establish the fact that when these ionic compounds separate into ions inside the cell, you will have positive ions and the negative ions. The positive ions will locate that rod which is negative. Have you seen it? The positive ion will locate one of the electrodes which is negative. What's it going there to do? When it gets there, it takes in electron to become a neutral atom. The neutral atom now is a neutral element which is deposited at that particular rod. The other way around, the negative ion inside the electrolytic cell will locate the positive rod, which is a positive electrode. When it gets there, what will happen? It loses electron to still become neutral atom. So this is what is happening now. This one will gain electron to become neutral. This one will lose electron to become neutral. Where does the gain of electron take place? At the cathode. And what is gain of electron in oxidation and reduction? Reduction reaction. Where does loss of electron take place? Anode. And what type of reaction? Oxidation reaction. Can you see how these things connect? From the previous topic, oxidation and reduction, we are dealing with electrolysis now. You see, that's why you must always pay attention when one topic is being treated before you move to the next. Okay. Now, having understood this, I want us to remember that we say that the electrolytes must be in molten or aqueous state. We want to look at the analysis of electrolysis when the electrolyte is in a molten form and when the electrolyte is in a what? Aqueous state. I am still using sodium chloride because sodium chloride, we can place it in an aqueous form, can also be in a molten form. Aqueous form in the sense that it is dissolved in water to achieve the mobility of ions. Then in molten form, it is not dissolved in water. Rather, instead, it is heated up. It is made to position it in a what? In a form that it can melt and still have the two ions, the positive and the what? The negative. I will also use lead bromide or lead-2 bromide. Lead is positive, bromine is negative, the molten one. So what happens using molten form of electrolyte? Please pay attention because this, after molten, when we shall be discussing aqueous form, you discover that we'll be having addition of ions which will not be in competition. So it is very clear that two of them have little kind of what distinguishes this from this. Permit me to still draw this electrolytic cell, which is a cell that converts electrical energy to chemical energy. This is the source of the current, or source of the current. This is the wire connected to what? A rod. And this rod is dipped inside a beaker or container. Then another wire is connected through this side, connected to another rod, which is still dipped inside this. Now, this one is a positive rod, and this is the negative rod. The positive rod I call the anode, while the negative I call the cathode. And I said current enters through this, while electron moves move out from this. This arrow is the flow of electron, while current enters as in opposite. Now the question is, where will be my electrolyte? My electrolyte will be here. This electrolyte can be in molten form or aqueous form. Please pay attention. Watch this. That if I have molten, did I dissolve the compound in water? No. The compound probably is heated up and it melts. Right? Making sure the ions are what? In a mobile phase now, they can move. But in aqueous form, you can achieve this mobility by dissolving it in water. So they are not exactly the same. Some electrolytes, some compound can be in molten and can also be in aqueous. An electrolyte such as sodium chloride, or electrolytes such as zinc chloride, you can dissolve it in water, the ions will be mobile, and that moment can carry current that is passing out. You can as well decide not to dissolve them in water, but melt them by heating them. You will still render the ions to be in what? Mobile phase. So take note. Now, what happens when these ions are produced without dissolving it in water? That's what I'm about to explain. So pay attention to this. Now, I want to use lead-2 chloride. What is the formula of lead-2 chloride? Lead-2 chloride is Pb. Pb is lead, right? Okay, lead-2 bromide. Let me use lead-2 bromide. Pb is lead. Bromine is what? B what? R. Lead-2, since it's lead-2, that 2 will come here. So Pb, capital Br2 is what? The compound called what? Lead bromide. If we say that this compound is in a molten form, you will not put aqueous here because it's not being dissolved in water. So what will happen? The compound is heated up and they melt and separate into two what? Ions. So the two ions we can produce from this are simply lead-2, because this 2 is actually coming from lead. Lead-2. And the next one is what? Bromine. Right? The next one is what? Bromine. So bromine is Br minus, which is actually coming from the other side. So, of course, you remember that bromine is one of the elements in group 7, the chlorine and the fluorine family. They are known for what? Forming what? Ions by gain of 1 electron. By gain of what? 1 electron. Okay, now this is what is happening when you use molten. There is no competition of ions. When the ions separate, you have just 2 ions. 1 positive ion and 1 negative ion. 1 positive ion and 1 negative ion. No competition. Take note. You will understand what I mean by no competition when I use aqueous. No competition. Once the compound is melted, is subjected into this molten condition, you just have 2 ions. Look at them. This is heated up. it separates and gives what? Lead-2 positive, bromide negative. Simple. Imagine where you are told to analyze, explain what happens in the electrolysis of molten lead-2 bromide. This is the first thing you will do. Show them the two ions that can be obtained from such compound. Immediately after that, one of the ions will move to one of the rods, and the other move to the other. Now, taking from the previous class, I told you that the positive ion here will definitely move where? To the negative rod, which is the cathode. Let's do that. That means inside here, I have lead-2 bromide. The moment the current starts passing through, what happens? The ions, which are already in mobile phase, definitely the positive move to one end. So I'll be having lead-2 here, and I'll be having bromide what? One what? Ion. Tell me, between lead-2 plus and Br minus, which one is positive? Lead-2. So where will this lead-2 move to between the two rods? It will move to the negative because lead-2 is positive. The positive moves to the negative, while the negative ion moves to the positive electrode. That means the lead-2, which is positive, is moving to the negative electrode. And the name of the negative electrode is the cathode. That is to say that the reaction taking place at the cathode, you now write cathodic reaction or cathode half equation. You are trying to explain what will be happening at the cathode. So we want to see what will happen here now. What is here? Here is what? A rod that is carrying a negative charge. Which ion from inside this place will come to it? The positive one. So lead-2, Pb2 plus. What happens when the positive gets to that? It picks an electron or add the electron to itself. How many electrons will it add? It will add the number of electrons that will cancel out these 2 plus. If we have just 1 plus here, 1 electron is used. If it has 2 plus, we shall be using 2 electrons. What does that mean? These 2 will cancel out this. And the result is what? Ordinary lead. Ordinary what? Lead, which is ordinary metal, solid. But where it is actually coming from is from here, inside this place. Eventually, this lead-2 neutral atom is produced and is deposited at this particular cathode or this rod where it is being what? Collected. Where it is being what? Collected. Have you seen it? Where it is being what? Collected. No competition at all. When it is molten, no problem. Positive move to the negative and negative move to the positive. So this is what happens at the cathode. Now, what do you think that will happen at the anode? The anode, the question is, what is the charge the anode rod is carrying? The charge at the anode, is positive. So go back to inside the electrolytic cell and ask yourself which one carries the opposite. If the anode is positive charge, that means you are taking to the positive charge the negative one, which is the what? Bromide ion. So reaction taking place at the anode is the bromide ion, which is Br minus. What happens there is opposite of what happens at the cathode. At the cathode, there is addition of electron. But at the anode, there will be loss of electron. Look at the arrow here now. The bromide ion loses electron to give us ordinary bromine. Where is that electron? You now add it here. E minus. But because bromine is still one of the what? Those elements that occur as a diatomic molecule. That means in equation, when you see them alone, they appear like this, Br2. So because of these two, you have to balance in terms of atoms. Remember our balancing of redox reaction? You balance in terms of atom by putting 2 here. After putting 2 here, the total of the charge here now will be this sign interacting with this number here, which is -2. And because of that, you come back to the right-hand side and put 2 by the side of the what? Electron. So -2 here will cancel out the -2 here, and you have neutral what? Bromine molecule, which is being deposited at this particular electrode. So they can ask you, what are the 2 products produced in the different electrodes in the electrolysis of molten lead-2 chloride? The answer simply means, this answer is, at the cathode, which is the negative electrode, lead metal is produced. While at the anode, which is the positive electrode, bromine gas is produced. That is the answer to that question. No competition. No competition. Now, imagine when we decide to use aqueous form of this compound. Aqueous form of this compound. Aqueous form of this compound. When we decide to use aqueous form of this compound, what do I mean by aqueous form? We are not just melting the compound and they will separate just into 2 ions. We are dissolving the compound into water. When you are doing that, do not forget that water contains also positive parts and negative parts. So what will happen? In all, you will be having total of 2 positive ions inside the electrolytic cell. You will also have 2 negative ions inside the electrolytic cell. Now, the question is, which one will be discharged and collected as a neutral atom in the respective what? Electrodes? That will take us to another section or segment which says factors that determines the discharge of ions during electrolysis. But before I move to that, we are going to understand, using a practical example here, when aqueous is involved. When the compound is not just being melted, but dissolved into a solvent that carries its own 2 ions. Watch. I'm going to use aqueous lead-2 bromide now. Aqueous lead-2 bromide. Aqueous lead-2 bromide. What does that mean? The lead-2 bromide is dissolved in water. First of all, let's ionize the lead-2 bromide. Let's ionize the lead-2 bromide. I have lead-2, this is it, PbBr2. The ions here are what? Lead-2 and the what? Bro minus. You can't stop here. Why wouldn't you stop here? We are dealing with what now? Aqueous. Aqueous. We are dealing with aqueous. Why wouldn't you stop here? You dissolve this inside water. This is water. What's the formula of water? H2O. Where you dissolve this compound can also be ionized. Can also give you positive end and negative end. What is the positive end of this water? Water carries hydrogen plus and carries OH what? Minus. And it carries OH what? Minus. Can you see it? And carries OH minus. So, when you are using aqueous form of electrolyte, inside the electrolytic cell here, you will be having total of 4 ions, 2 positive and 2 negative. The question is, what contributed to the 3rd and the 4th ions? These 3rd and 4th ions are coming from water. Water has hydrogen plus and the OH minus. So, If you add it with the positive ion of the main compound and the negative part of the main compound, you will achieve 2 positive and the 2 negative. Now, during electrolysis, when current will now start passing through, which of these ions inside will go to the electrodes? That is the question. That is the question. Understand it at this point, because the next time I'll be talking about this, we shall be discussing factors that affect the discharge of ions. And after which, before we now move to what? Faraday's first law and second law, and finally the application of this topic. Okay, now this is what happens. Now, can we now look at electrolysis of molten sodium chloride and the aqueous sodium chloride? Let's look at molten sodium chloride. Let us still keep the electrolytic cell intact. We are using it, but inside the electrolytic cell now, inside the electrolytic cell, what we have there will no longer be lead, 2-bromide, aqueous, and molten, but what we are going to have here is now sodium chloride and the water. So the sodium chloride, sodium is positive, chlorine will give us chloride ion, which is negative. In water, hydrogen is the positive side, and okay, let's take them one at a time. I want to make use of molten first. Molten sodium chloride, molten. First of all, I want to use molten. I want to use molten. What does that mean? Can you remember what molten means? The compound must not be dissolved in water. The compound will be heated. It melts. The 2 ions will still show up. Right? That's molten. So what does that mean? I am using only sodium chloride. So when it is heated, when it is being melted, I have sodium ion, which is positive, and I have chloride what ion. Just 2 ions. You don't have any problem of which of them will move to the cathode and which of them move to the... No problem. Just take note. Sodium ion is positive. So it moves straight away to the what? It's positive. So it's going to move to negative rod. What is negative rod? Cathode. That means the reaction taking place at the cathode will be the positive charge ion will pick up electron there. How many electron? 1 electron, because we have only what? 1 positive here. Meaning positive and negative, 1, 1. It will give you what? 0. Minus. With this reaction, this and this cancel out. The result is what? Ordinary sodium what? Metal, which is being deposited here. Have you seen it now? Why are the anodes? What is the anode? Anode is the positive electrode. Check these 2 ions. Which one is negative? It's chlorine. Chlorine moves there. At that point, chlorine will not gain electron, but chlorine will do what? Lose electron to produce neutral what? Chlorine atom plus an electron. This arrow means loss of electron. But chlorine here is a diatomic molecule. You have to go with 2. You have to balance the equation by adding 2 electrons. What am I trying to explain here? The moment is molten. 2 simple ions are produced, positive and negative. Then during the process, as the current is being passed through, the positive ions inside the electronic cell will migrate to the negative electrode, while the negative ion inside the electronic cell will migrate to the what? Anode, which is the what? Positive. Now what happens? At the cathode, there is gain of electron, which is what? Reduction reaction. And what happened at the anode? At the anode, there will be loss of electron, which is what? Oxidation reaction. Each of them producing a neutral atom, which are deposited in their various what? Those various rods. That is understood. Now, the same sodium chloride, I want us to dissolve it in water. Dissolving it in water, you will not call it molten again. What are you going to call it? You call it what? Aqueous. Water is now involved. You are not just having only 1 compound now. you are having two compounds. And these two compounds, each produces two ions. Yeah? Each produces two ions. Two positive and two what? Negative. Okay, let me do it. We are now dealing with aqueous. Aqueous sodium chloride. Aqueous simply means this sodium chloride is dissolved in what? In water. Have you seen it? So, the sodium chloride, if we ionize it, you have sodium ion and you have chloride ion. For water, the ions present in water molecule are what? In water compound is what? Hydrogen ion and what? Hydroxide ion. OH what? Minus. So look at it now. This was dissolved in this. Total of how many positive do you have here? 2. This and this. How many negative? This and this. Because of this reason, there will be competition of which ion will be discharged at each of the electrodes. The sodium ion positive and hydrogen ion, both of them will migrate as long as electrolysis is taking place. The moment you start passing current through this point, once it gets to this, because at this juncture, you will not have only sodium ion and chloride ion, you also have what? Hydrogen ion and OH what? Minus. So the positive ones will be moving to the negative electrode. That is, sodium ion and hydrogen ion, both of them are positive. They will move to the cathode. But getting to that cathode, one is discharged in preference to the other. That means one is being pushed back. So the other one says, go back to inside the cell. I am the one that qualified to move out and come out as what? A neutral atom. There will be a competition between these two what? Positive. Which one will actually go out and become a neutral element, which is collected as a chemical, and which one will go back inside the electrolytic cell? After this, the negative, which are also 2, will have the same competition. 2 of them will do what? Will migrate to the anode, where one will subject the other one, go back. I am the one to move out. Are you seeing what is happening? For molten, do we encounter this? No. Molten is just, the substance is heated, it melts, separates into 2. One positive, one negative. The positive one start locating the rod, which is an electrode, which is what? Negative. While the negative ion start locating the rod, which is what? Positive. Are you seeing it? But coming to aqueous, there will be a competition. Then how do we solve this? How do you know the one that will go out as a neutral entity? And how do you know the one that will come back? How? How do you note that? We consider some factors. What are these factors? That is where we are going to stop today. We are going to mention these 3 factors, and in a subsequent class, we shall apply these 3 factors in the analysis of electrolytes in their aqueous form, because molten form has no issue, no problem. In their aqueous form, we shall be using these 3 factors to note or to determine which one will be discharged in preference to the other. So what are these factors? Factors that affect the discharge of ions during electrolysis. Factors that affect the discharge of ions during electrolysis. The factors are, number 1, the position of the ions in the electrochemical series. The position of ions in the electrochemical series. We have potassium, which is the most reactive. We have sodium. We have calcium. We have magnesium. We have aluminum. We have zinc. We have iron. We have tin. We have lead. We have hydrogen ion. We have copper 2. Okay? We have silver. We have mercury. We have gold. Then we have platinum. just like that. If you watch this, the most reactive here is potassium. Okay. Which one will discharge? Imagine I have between sodium and the hydrogen. Remember, I have sodium ion here and I have hydrogen ion. Imagine these two are inside the electrolytic cell. Which one will be discharged? The one that will be discharged is the one that is less reactive. The one that is what? Less reactive. So between sodium and hydrogen now, which one is less reactive from this arrangement is what? Hydrogen. So the preferential discharge of the ions takes this direction. Look at it. The lesser the reactive of that particular ion, the more potential it has to be discharged. Then the other one will now move back inside the electrolytic cell. So if the competition is between sodium ion and the what? Hydrogen ion. It is hydrogen ion that will be discharged, that will go to the what? Cathode, where it picks an electron and finally become a neutral hydrogen atom, which will now represent a hydrogen molecule. Have you seen it? Have you seen it now? So that's exactly what is happening there. For the negative part, the one we usually encounter are the following. We have fluorine, which is the most reactive non-metal. After fluorine, we have the sulfate ion, SO42 minus. We have the nitrate ion, NO3 minus, right? We have the chloride ion. We have the bromide ion. We have the iodide ion. And we have the OH what? Minus. The preferential discharge of these ions also takes this direction. As you move down, the one below has the potential to be discharged in preference to the one on top. So what am I trying to say? Imagine if it involves Cl minus and the OH minus. OH minus below. That means it is OH that will be discharged in preference to what? Chloride ion. We shall use this in real analysis in the next segment of this. Now, that is one of the factors. Which factor have I just explained? Position of these ions in the electrochemical series. What I have written here, this is the electrochemical series of the positive, and this electrochemical series of the what? Negative. And the second factor is the concentration of the electrolytes or of the ions. If the electrolyte is concentrated, you find out that the ion that's supposed to be discharged under this position will no longer be discharged. Instead, the other one will be discharged. The one that is more concentrated will be discharged more than the other that is not concentrated. And finally, the last factor is the nature of the electrode. The nature of the electrode. What is that electrode made of? Is it an active electrode or is it an inert? Inert means unreactive. Okay? So these are the three factors. We shall use these three factors to discuss more on what happens in the electrolysis of aqueous solution. Before we now look at the what? Faraday's first law and the second law. Till then, bye.